function composition. We want to evaluate each expression by hand. We want to give our answers in radians. We'll look at the first one, sine inverse of sine of 2 pi over 3. Be very, very careful with these, especially when the inverse function is on the outside, as it is in these two examples. I know that it's very tempting to say, oh, sine inverse and sine, they cancel each other out. So the answer here must just be 2 pi over 3. Well, there is absolutely no way that the answer can be 2 pi over 3 because 2 pi over 3, that's 120 degrees. That's outside the zone of what the inverse sine function knows about. The inverse sine function has never heard of 120 degrees. It only knows about angles between negative 90 degrees and positive 90 degrees. So that is definitely not the answer. You say, well, how can we get the answer then? We're going to have to work this out in pieces. The first piece would be to find the sine of 2 pi over 3. I should be able to do that reasonably easily. 2 pi over 3, 120 degrees. Draw a reference triangle. Let's see, this was 120. That leaves 60 here. This is going to be a 30, 60, 90 triangle. I know how to fill that in. 1 square root of 3 and 2. The 1 would be negative. It's going off to the left. Well, that means the sine ratio, let's see, sine is opposite over hypotenuse, so square root of 3 over 2. So sine of 2 pi over 3 came out to be square root of 3 over 2. Now I need to find the inverse sine function for the ratio square root of 3 over 2. Well, I'm going to have to draw a fresh picture because inverse sine doesn't know anything about the second quadrant. Inverse sine only knows about quadrants 1 and 4. Root 3 over 2 is positive, so that means I should be drawing a first quadrant picture. Let's see, opposite over hypotenuse. It's still a 30, 60, 90 triangle. Here's the 60 opposite the root 3, but that's the angle that would be the answer to this problem. 60 degrees in the first quadrant, or pi over 3 in radian measure. You can see why this is tricky. If you're outside the restricted angle zone, you're going to have to work it out in pieces in order to get the right answer. Let's take a look at the second one, cosine inverse, cosine negative 5 pi over 2. Again, cosine inverse has never heard of the angle negative 5 pi over 2. It only knows about angles between 0 and pi. So I'm going to have to, once again, work this thing out in pieces. Let's see. Negative 5 pi over 2, anything with a 2 on the bottom is a quadrantal angle. So I should definitely draw a unit circle picture. I'm rotating around in a negative direction. 5 halves is 2.5. So I need to rotate around negative 2.5 pi. Let's see, here would be negative 2 pi, and then another half of pi would take me to here. Here's the spot on the unit circle we're talking about. This is the point 0, comma, negative 1. The cosine function on the unit circle returns to me the a coordinate. So that would be 0. Well, then I can go on to find cosine inverse of 0. I'll need a fresh picture. A cosine inverse doesn't know anything except angles between 0 and pi. That's this section of the unit circle. I need to find some point in this section of the unit circle where there is an a coordinate of 0, 0 comma something. Well, the only such spot is right up here at the top. Here is the spot 0 comma 1. There is no other 0 comma anything in our restricted zone. What angle is that? It's obviously 90 degrees. It's pi over 2. And that would be the answer to the problem. Thanks for watching.